Hello, hello, hello. Today we are going to be balancing a chemical equation. It's our very first basis of stoichiometry. Before we get too into it, we need to ensure and understand the concept of stoichiometry and what exactly is this. So stoichiometry is essentially working on different parts of the equation, the left and the right side of the equation. And this looks a lot like algebra. It's the idea of taking numbers and ensuring that you're computing in the same way on both sides of the equation. So stoichiometry is a lot like that. It is not scary. So first off, I have written out the equation that we are going to balance today. Before we get started, we need to create an element inventory. So an element inventory is essentially there to keep track of the number of elements that you have on each side of the equation. So first, we are going to do the left side of the equation. So we're going to count up the number of iron atoms that we have. We have 2, oxygen, we have 3, and carbon, we have 1. We do the same thing on the right side of the equation. So we have 1 iron, 1 oxygen, and 1 carbon. Now we look at this and we realize that the number of elements that we have on both sides do not line up. So for example, the number of iron does not line up, and the number of oxygen does not line up, but the carbon does. So what do? We balance this equation, and when we balance this, we manipulate the coefficients. Now, before we begin to do that, we need to get a proper understanding of what a coefficient, what an element, and what a subscript is, and what we can or can't change. So this is the element, or let's give it variables, right? So right here we have the element. Let's just call it M. M is the element. You do not get to change this. Do not change this. The subscript is S. Now S, once again, it tells you the number of elements that you have. You also do not get to change this. But this right here, Z, is the coefficient. You can change the coefficient. So you can change the pink, but you cannot change the red. Now, in order to get the number of elements in a compound, we can create a very simple formula. You don't need to memorize this because it's basically common sense. So in order to get the number of elements in a compound, we simply multiply the coefficient times the subscript. So Z times S. That will give you the number of elements in a compound. Now, going back to our question right here, we know that iron and oxygen, the number of atoms of iron and oxygen, both sides of the equation, do not line up. So the only thing that we can change is the coefficient. So in order to manipulate this, what are we going to do? Well, first, right off the bat, I notice that there aren't equal amounts of oxygen. So I'm just going to put a 3 right here. Now, since I made a change on the right side of the equation, I must quickly change up my inventory as well. We want to keep our inventory up to date. So now we have matching number of oxygens, but we do not have matching number of carbons. So now what are we going to do? Well, the carbon right here, so we want the carbon on the left side of the equation is just by itself. So that is a very easy and quick fix. You can just write 3 right there. Once again, we made a change, so we must quickly update our inventory. Next, we have iron, and iron once again is by itself. So that is a quick, easy little change. And just write a 2 over here, and there you have it. The number of iron, oxygen, carbon match on both sides of the equation. So therefore, the balanced equation is Fe2O3 3C 3CO plus 2Fe. And that is as simple as it is. Next, there are certain exceptions, or there are certain shortcuts per se that we can make when it comes to balancing chemical equations. For example, there are certain diatomic elements on the periodic table that like to be diatomic, as in they like to exist as pairs, and those are considered to be in Brinkelhoff. So B, Brinkelhoff. So all of these elements love to be as diatomic, but one great thing when it comes to balancing these is that you can write them as fractions. Now, this depends from teacher to teacher, but typically fractions are also acceptable. So let's do an example over here with fractions. So you can write CrO3 equals Cr2O3 plus O2. Now, right off the bat, I see oxygen right here, and I know that this is diatomic because of the 2 on the subscript as well. So we can begin by creating our element inventory on both sides of the equation. We have 1 chromium and 3 oxygen, 2 chromium, and 3 plus 2 is 5 oxygen. So this is clearly not balanced. So we're going to put a 2 right here so that we can match up the chromiums, and results in 2. I'm going to quickly update our inventory. So 2 times 3 is 6. Next, we have 2 chromiums. The chromiums match, but the oxygens do not. So now what do we do? How do we get 6? So we know that 3 plus 3 is 6, but we cannot put a 3 over here because 3 times 2 is 6, but then it just wouldn't work out. So how would we add an odd number in the coefficient? We simply put it as a fraction. There you have it, 3 over 2 oxygen. So now that you add it, it's going to be 6. Now, let's say your teacher does not want you to use fractions. Well, it's quite simple. You just take this entire equation and multiply it by 2. When I say multiply, you can only change the coefficients. You cannot change the subscripts. So the balanced equation without fractions is is this. I'm currently trying to write it. And there you have it. That is how you learn to balance equations. It would definitely be very helpful to do tons of practice questions, and I'm sure you guys will do it. I hope this helps.